Okay, so let me get your attention up here. You can't be lost already. That's against the rules. Okay, eyes and ears, focus up here. Don't let food be a distraction. I wouldn't let food touch these desks, just so you know. If you've ever washed one and then looked at the cloth after you wash it, yikes, dude. I'm just saying. All right. So, not to scare anyone, but okay. So, we're dealing with tangent function today, 95. We set our graphing window to 0, 2 pi, pi over 8, negative 4, 4, 1, 1. Their respective values there. Everyone pause just for a second. Look right here so that you understand what's expected here. You're expected to graph y equals tan theta. Now remember, theta is actually x. It's the x value. It's not the theta key. There's an actual theta alpha key, I think, on there.
Yeah, alpha
okay? 3. It's not that. It's the x value. So in your calculator, say tan x. Okay? You need to put down a for this equation. Put down b from this equation. And then once you see the graph, I want to know how many cycles there are and what the period is, the length of one of those cycles. Okay? Remember, that'll be helpful if you look at this, because this is your x minimum, your x maximum. So if you see 2 repetitions on this, or 3 repetitions, that means, if you see 3 repetitions, that means you have 3 cycles from 0 to 2 pi, meaning the length of one of those cycles, or the period, would be 2 pi over 3, right? Since you see 3 of them. But I'm going to let you figure that out, and then I need to know how, like, in general, how do we find the period? Some of you aren't paying attention. I've lost you already. In general, once you get all this filled in, how do we find the period? What's the formula for the period of a tangent? Okay? It's not 2 pi over b. That's why we're doing this. Otherwise, I'd just say, hey, it's the same thing as sine and cosine. Okay? And then the number of cycles from 0 to 2 pi. What's the formula for that? It is not b, like sine and cosine. It is different. In fact, your tangent graphs are going to look a lot different. Okay? So right now, let's go ahead and put the y equals tan theta in, graph that one, fill that out, and then keep going all the way here. Someone that has a TI-83, after you get y equals tan theta in, can I see your graph, please? Your calculator? Okay? Now, many of you, those of you who have an 84, your graph's going to look different than that, right? On the 83, you get these straight lines. Those are asymptotes. You shouldn't graph those. Those should be dotted lines on our graph when we graph later. That's actually an asymptote, and that's an asymptote. Those of you who have an 84, you don't see those. Okay? All right. And that's okay. Just note that they're asymptotes. All right. Give you some time. Work with your groupies. Ladies and gentlemen, take a look at there. Compare your answers. All right, many of you had the table completely filled in. Some of you had none of it filled in. And then a couple of you were still about halfway to a quarter way left. All right, so it's easier to fill that in when you know what your window was. Remember, our windows went from 0 to 2 pi on the x, negative 4 to 4 on the y, and then went up by 1s on the y and up by pi over 8 on the x. Okay? Now, based on this, what was the period?
It was b over
2 pi over number of cycles.
yeah, pi over b.
Yeah, pi over b. Now, how many of you actually figured that out by looking at your graphs? Well done. Okay, how about number of cycles? 2b.
Or not to be.
Good.
Raising the track.
Okay, so we see that if we have, that isn't a question. Okay, if we have pi over b, if we take b, put over pi, we get our period every time. Pi over 2, pi over 4, pi over 1, pi over 1, pi over 2. And then as we get down here to 2b, the number of cycles is always twice what our b term is. Okay, that being said, remember that cosine and sine, the period was 2 pi over b. And number of cycles was Wasn't that? What was the number of cycles for sine and cosine?
B.
It was always our B term. Okay? Algebra's out of control next door. Unbelievable. All right. Moving on. Hey, any questions there? Okay, moving on. We're going to be graphing. Remember, we're doing 23 through 37 today. For those of you that don't like to go out of order, or maybe you're a little type A, you've got to have your graphs numbered correctly. Start with 23, and then pre-number them. All right? We're going to do this first one together. This is the parent function, y equals tan theta. Okay, I want everyone to label A and B. You get 15 seconds. A and B. Okay, very good. A equals? 1. B equals? 1. Okay, A's right here. Our A term, there isn't one, so we put a 1 in. Our B term is right there. There isn't one, so we put a 1. All right. That is horrible focus. My goodness.
Do the Carter method.
I was literally thinking Carter method.
Go to the Carter method.
Put the C on.
I'm glad I can be of assistance.
Oh, yeah, we appreciate it. All right. That helps out a little.
We can call it your friend. The Carter focus method.
And then I autofocus and it messes up again. Okay, so the little jingle that we use for this one is 0A asymptote negative A0.
That's a jingle.
Yeah, I know. I heard it wasn't a jingle last period, but I figure if I keep saying jingle, eventually it might come true. Someone last period said it was a chant. If you go down the hall chanting that, people will look at you weird. Okay.
0.
So we're gonna do that.
Just all of us in one room.
Okay, so 0. What's our A term? Everyone, what's our A term? 1, so we go to 1. Asymptote, we're going to go through and just put that dashed line there. Negative A and 0. Okay, and we graph. Bless you. Bless you. Yeah, we frown on that. Okay? So there we got it. All right, we know that the period of this is pi over b. So in this case, b is 1. So the period is equal to pi over 1.
Or pi.
Or just pi. So that means one complete cycle has a length of pi. When we're graphing these, we are going to label both the zeros and the asymptotes. So if that's pi, that makes this asymptote pi over 2. It's halfway from 0 to pi. It's pi over 2. Okay, we need a graph. I want us to graph from 0 to 2 pi. Okay, so we need to now, I'll use a different color here. Just joking, we'll use the same color. So we've got A. Here's a funny joke. All right. Please notice that my graphs they're shown as slides through the x-axis. Make them look like slides. Make them slide the appropriate way. Okay, it's like a half parabola. It's not a parabola, but it kind of, the way you're drawing it. The way you're drawing it kind of feels like a parabola. Okay?
You don't want a boring slide.
You don't want a boring slide, yeah. So that's 2 pi. This is 3 pi over 2, right? 1 pi over 2, 2 pi, 3 pi, and 4 pi over 2, which is 2 pi. Okay. How many got it? Now, whenever you have asymptotes, what do you usually have? What does an asymptote mean?
Never crosses that line, but it gets.
Okay, it gets infinitely close to it, never crosses it. How have we had graphs with asymptotes earlier this year? Like, what caused us to have an asymptote? Yeah.
Exponentials?
Okay, not exponentials.
Logs.
I guess exponentials, if you think of it, yeah, I guess you can think of that as an asymptote. No, it was last chapter, man. We forgot all about chapter 8 already. Bless you.
I forget what it's
I thought
called.
we were on
Something over
chapter
X?
7.
Anything over.
Sarah?
Yeah, anything over X.
Good. Whenever the denominator is 0, we got an asymptote. How are we going to get a denominator equaling 0 here? We don't even have a denominator. Let's think back to this trusty old thing. It is a circle. Some even like to call it a unit circle when this is equal to 1. Okay? Yeah, I'm pretty impressed with my circle drawing lately. I've been practicing.
Really?
Yeah, I just sit at home on the weekends and draw circles.
Really?
You're like Da Vinci. That's what he did.
I know. You walk into my house, that's all there is everywhere. Circles. It's kind of creepy. Weird. All right. My kids are like, yeah, anyway. All right. All right. It gets bad if you start calling your dog radius and your other dog diameter. All right.
Dylan or boy?
Hey, just so we're clear, I don't do that on the weekends. I don't want you to think that. And my dog's is not named radius or diameter.
Circumference.
Hi.
No, sir.
Yes. I know these people.
He's knighted.
Okay. Hey, think back to our unit circle. This is the length of 1. What did we call this?
1.
We call that cosine.
We did call that cosine. Also happens to be our x value. What do we call this? That was called sine. Also known as our y value. So whenever we found coordinates, for instance, like this coordinate right here, this coordinate up here was cosine sine. What's the ordered pair here? 0, 1. 0, 1. So what about this coordinate? This one is 1. No. 0, negative 1. That was a close one. In pen.
Close one.
Close one. All right. Zoom right on into that piece right there so we can see. That's horrible focus again. Use the Carter approach.
Carter method.
Well done there, Carter. All right. So,
You almost call me a whale?
no.
I was like,
But my dog's name is Orca now, talking about whales. Seriously. I know. It's black and white, and it's not as big as a whale. Okay. So, 0, 1, or 0, negative 1, 0, 1. Stay with me now. How many remember this little chant? Soka Toa. Now that's a chant, not a jingle. Sorry. Okay. We'll talk about this in 9.6 again, but staying with me, this is sine. Okay. Opposite. So if we're talking about this angle, right there, our theta angle, sine is opposite over hypotenuse. So the opposite side over 1, which in this case is sine. Cosine. Good. So the adjacent side, the one touching the angle, over the hypotenuse, which in this case is 1, so it's adjacent. What is tangent? Opposite, which we are calling
sine.
sine. So just so we're clear here, tan, make sure I'm still on the screen, is equal to opposite over adjacent, which is the same thing as sine, the opposite, over cosine. Now, if tangent is sine over cosine, sorry about that, so sine over cosine of theta, that's another way of thinking of this. This actually says, rather than tan theta, we could say sine over cosine. You guys with me? Sine theta over cos theta. Well, cos theta is what? What? X or Y?
X.
That's X.
X, right? Alphabetical. Okay? X.
So it's
See?
y over X.
So look here. Cosine 90 is, yeah, it's pi over 2. And at pi over 2, cosine is 0, which means this is undefined at pi over 2, which is why we have that asymptote there. And it's also undefined at 1 pi over 2, 2 pi over 2, 3 pi over 2. That's when cosine is 0. That's why we have an asymptote there. You guys with me on that? Okay, that's algebraically why it works. Now, we'll see that a little more as we go, but understanding that tangent means sine over cosine. Okay, so wherever cosine equals 0, you're going to get an asymptote because the bottom of the fraction is 0.
So that
Yeah.
also explains why P equals pi over B, doesn't it?
Why is that?
Well, because in order to go from halfway around the circle, which is pi, you have to go from one asymptote to the other.
Yeah, that's it. That's another way to think about it. Yeah, that's one length of pi. Good. Everyone understand what he just said there? That explains why a period is pi over 2. He's saying that to go from here to here, or from one asymptote to another, so that you get that repetition. If you think of your asymptotes as your repeating values, your repeating pieces, this length is, that length right there is pi. Okay, and so that's how Connor's seeing it. That's a length of pi from asymptote to asymptote. Good. Another way to think about it. Any questions there? Okay. Very good. Sorry, I didn't want to spend that much time on it. I did. So, number 26. Moving on. Give it a go. Okay, A equals -3, B equals 1. Period then is pi over 1, or pi. Number of cycles is going to be 2 times 1, or 2. All right, so we've got 0. Now, in this case, A is -3, so when we go down, or when we start this, we go down to -3. Put our asymptote. And then we do -A, which is -3 or +3. If you want to think of that, you just switch to the other side. The negative just means we start by going downward. All right? And so I should really be using a pencil here. All right? So there's one of our cycles. The length of a cycle is pi, which makes this pi over 2. Don't what?
He doesn't understand Erica.
Staring at me.
That came out weird.
It's a statement of fact.
Not really.
You
A matter of opinion
Technically,
or statement of fact.
All right. So moving on. There we go. That curve's bothering me. Sorry. That's the type A in me.
Type A.
A.
I guess we're Canadian
That's
too.
funny.
No, Brooks is Canadian.
Is it
I'm Canada.
All right, eh? There we go.
Do you speak
Do you speak Indian?
How many got it? Questions? All right, everyone rate themselves 1 to 5. Okay, so we shifted with A. Let's put a B in there. Give that one a go. Hey, you're doing your work right now, your homework. That's good. Okay,
To be or not to be?
everyone write down what A and B are right now. Let you write down the equation first, I guess. Function.
Someone's coming.
Mm-hmm. I guess.
Thank you.
Yeah. Let's be like you're in here again during this lesson. There you go. What's A?
-3.
-3. What's B?
2.
2. Period is pi over b, which is
2.
pi over 2 or pi over 2. All right?
What?
2b is the number of cycles, or 2 times pi over 2. 2 times pi over 2 is pi. Oh, yeah. Pi, oh, pi. There we go. Graph it. Okay, it was pointed out to me that the number of cycles is incorrect. Unbelievable. Let's try that again. 2 times 2.
That makes more
Wow.
sense.
That is 4. Good. Can't believe we made that mistake. Okay, so we go 0, negative a, asymptote, should be dashed, positive a, 0. There's 1 cycle. Negative a, asymptote. There is a 2nd cycle. We need to get 4 of these in here.
Just need 3 full squiggles and then 1 half squiggle.
Mhm.
1 half square.
3 full squiggles and 1 half squiggle.
These?
To put it in math terms, there's 3.
Very mathematical.
All right. I think we've got it, according to Carter. As long as we have 3 full squiggles
In 1/2 square.
and 1 half squiggle.
Yes. Perfect.
Uh-oh.
Three squiggles and 1 half squiggle.
Not dope.
Okay, yeah, we do have 1, 2, 3 full squiggles and 2 half squiggles, which make our 4th. Okay. Hey, the length of one of those, or from 0 to 2, the length of our first cycle is pi over 2, which makes this asymptote, which we're also labeling pi over 4, 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4 or pi, 5 pi over 4, 6 pi over 4 or 3 pi over 2, 7 pi over 4,
Who's doing that?
and then 8 pi over 4, which is 2 pi.
So, do you want us to label zeros and asymptotes?
Zeros and asymptotes. The other thing I don't want you to do is get all yippity-skippity with it. Those of you that I've been looking at some of your rational function graphs, and you do this, remember it has to pass a vertical line test. You only touch the graph in one spot when you have a vertical line. So those of you who get all happy, joy that you're done graphing, you're like, woohoo! And I'm like, well, dude, that's not even a function anymore. All right? It's nothing. It's, well, what I like to call it usually is wrong. So, incorrect. So, let's, now my graph's all messed up. I'm not happy, joy.
Not happy fun time.
Yes. There we go. That makes me feel so much better. Okay? Yes, Samir?
So the b equals 2, it's just showing that there's 2 squares in between every asymptote.
No. That's telling us there are twice, the number of cycles is always 2b. So in this case, 2 times 2, that means there's 1, 2, 3, 4 cycles.
From 0 to 2 pi, but so what's the b on the graph? Like, where is that? Or is it just for that?
That's what B tells us. That's it, yeah. Okay? Yep. All right, hey, let's give number 30 a shot. Everyone tell your neighbor what the scale is going to look like for number 30. Hey, we know A equals 5. B equals what? Pi over 2. The scale is going to be missing what value? It's going to be missing pi. It's going to go up by units because pi appears in B. Remember that?
Yeah.
Okay, so when we're calculating this, period is equal to pi over B, or pi over 2. And for those of you who remember the shortcut on that, you just move the 2 to the top. Okay? For those of you who can't remember the shortcut, I'll go through this just one more time real quick. That's pi divided by pi over 2, which we actually flip the back and multiply. So that's pi times 2 over pi, which those cancel. So you just get 2. So if you just move the 2 up to begin with and cancel the pi's, you would have been there. Okay, so the period is 2. Number of cycles is 2 times pi over 2, which in this case is pi. Pi oh pi. All right? Very good. So go ahead and graph it.
You actually call him a little person.
That's average.
Oh wait, I don't need to do
Yeah, I
this.
have. Remember the day that I talked to you and you screamed at me for like 2 minutes?
That's like moderate.
Okay. Trust me, you guys have never seen it.
No, we haven't.
Have you gotten ripping books with half hungry?
Pretty close. Because I would never troll them.
Okay, what's the length of one cycle? It's 2. Okay, this is 1. By the way, it says our period is 2. That's how we know that. And then the number of cycles is pi. Pi represents what number?
Oh,
3.14. So we're going to have about 3 cycles, a little more than 3 cycles.
okay, I did that right.
I think I got it.
Having some major issues drawing my curves. You keep your eye on. If you keep your eye on the point when you're drawing your curve, it makes it a little easier. Like when I'm drawing this line from this point to this point, I'm actually looking at that point. Generally makes it easier to draw your curve. Now when I say general, see, not always. I have a hard time drawing that way.
It's not nice.
I have to turn my paper.
Put your nice pants on.
That's still bad. Believable.
Putting nice pants on?
Why am I putting nice pants on?
So pants are optional. At home.
What are you talking about? Still not great.
Pants are optional.
I don't like pants. I like shorts.
I mean, technically, yeah, they are.
I get disturbed with what you guys talk about up at this table.
Is that thing
Okay.
recording?
I did too.
Yes. So this is 3.
Optional pants.
That's 4. That's 5. This is 6. And
0.28.
0.28ish, right?
It goes up farther.
So right about there. We're calling it good there. This is a quarter, right? Oh, hold on.
It needs to go up farther.
Yeah, we'll go up a little further. There. All right. Good.
I can make funny noises if I want.
Okay, how many have it? Very good. Any questions?
How did we figure out that one increment or one length is 1?
Well, we know that a length, the period is 2. So here's a period right here. And then half of 2 is 1.
Period is what again?
Ew.
Erica, we need to be done now. Okay, period is 2. Half of that is 1. Okay? All right. Hey, guys, I am going to leave this up here for you to read if you'd like to. This is out of the textbook. It gives you a visual of what tangent is. When we get to topic 3, I'm actually going to go into what tangent looks like along with the other 5 trig functions. So all 6 of them you'll see in relation to the unit circle. But if you want to read that, great. If you don't, and you want to wait till topic 3 and let the anticipation build, that's fine as well. Okay? Here we go.
Anticipation.
Wasn't that basic?